Welcome back. So we're gonna jump into example 6, and we're gonna review again some of the systematic process that we have to find the absolute extrema given a function without actually giving a graph, right? So the technique that we have sort of discussed before to find the absolute extrema is to find the critical numbers and then use the critical numbers along with the endpoints to compare all their y values. And then, so we're gonna jump into this problem, and do it with this example. So you guys heard me said we're gonna find the critical numbers, and so let's jump in with the critical numbers, right? So so the critical number is happens whenever the derivative is zero. Whenever we have a derivative that's equal to zero, or whenever the derivative is undefined. So here we go. So that means we have to find the derivative of this. So the derivative of f is going to be f prime of x. The derivative of 3 is 0. The derivative of minus 7x squared is minus 7 times 2 is negative 14 times your x, and then subtract 1 from the power. So 2 minus 1 is 1. But we're not going to write the 1, we're just going to leave it as it is. We're also given the endpoints of the graph, so let's keep that in mind. The endpoints is x equals negative 4 and x equals 2. These are the end points, right, of the function. So to find the critical numbers, we will find whenever the derivative is 0 or undefined. Well, we already know that this is a polynomial, and so polynomials are known to be defined everywhere. So therefore, this is never going to be undefined for any real number x, right? So we can discard this case. So we're only going to have this case then. So we're going to set this equal to 0 then, and find the x values. Find the x values that makes the derivative be 0, right? Find the derivative that makes this be 0. So we could do this by just simply dividing both sides by negative 14. So we have negative 14 times x equals to 0. Divide both sides by negative 14. And so we end up getting x equals 0. So this is a critical number, right? And then we have, and we know it's part of the domain because it's a polynomial, the function. So what we're going to do is, all we have to do is compare these values, right? In order for us to find the absolute max, we just have to compare all those numbers and plug it into the original function. So we're going to use the original function. And use the critical number. So in this case, x equals 0. And plug it into the function. And we know that 0 squared is 0 times 7 is 0. 3 minus 0 is 3. And then we're going to use the endpoints. X equals negative 4. Right, so we're going to have negative 4 squared times negative 7. 3 minus that number. So we put this in the calculator, we're going to get negative 109. The other endpoint that we have is 2. So let's plug in 2. Notice that we're putting this in the original function. So we end up getting negative 25. Right, and that's it, right? So you actually put it in the original function. We don't even have to determine whether we have a local max or local min. We don't care about that. We only use the critical numbers and the endpoints, and just pretty much now compare, right? What is the lowest value in this function? Well, we can see it's negative 109. So the absolute minimum, the absolute minimum is actually negative 09, and it happens at x equals negative 4, because that's the lowest value of the function, right? And then there's nothing lower than this number, negative 19, in the entire function between negative 4 and 2. Now, between negative 4 and 2, the highest value of the function is going to be 3. And it's going to happen at 0. So at the critical number, you end up having the highest point on the graph. So we'll highlight that with, this is the actual absolute max. And there you go, right? So it seemed a little more straightforward, because we don't actually have to test whether we have a local max or local min. We just literally use the critical number and the endpoints, right? And test them into the original function. Right? And we just want to compare their y values. That's what I mean by that, right? We have the only places where the function can be global extreme on the limit interval are the critical numbers, critical points, or the endpoints. If the function has only one critical point, and if it's a relative local extrema, then it's also an absolute extrema. We don't actually have to know that, but we can just see it from the testing. If there are endpoints, find the absolute extrema by comparing the y values of all the critical points and the endpoints. When in doubt, graph the function to be sure. However, unless the problem explicitly tells you otherwise, it's not enough to use that